After we discuss about the classification, it is time for us to look into the other category of the data mining algorithms, and this is what we call cluster analysis. You've seen these slides before. Basically, it tells you that if the class label is provided for you to do the training process, this is what we say known as the supervised learning, which is like if you know people is going to buy a computer or not, if you're going to know the wine's label is greater than 90 points or less than 90 points. Those are what we call the labels. And therefore, if the labels are presented when you do the data mining process, that is what we call the category of supervised learning, which is most likely to be the classification or regression. On the other hand, if no labels are provided, this is what we call unsupervised learning. And basically, this is going to be the major category of the things that we want to learn in this topic. So what is clustering? Clustering is basically a collection of data objects. What you're trying to do is simply putting similar things together and then try to form different groups for different things, similar to one another within the same cluster. So if they are similar, you want to put them into the same cluster. If they are not, then dissimilar to objects in other clusters. That's what clustering trying to do. Clustering analysis is trying to find similarities between data according to the characteristics or attributes that we try to provide to the algorithm found in the data and grouping similar data objects into clusters. So you may be wondering, what is really this for? You need to understand this. Clustering analysis is actually a very important human activity. For example, when you are young, you look into small animals. We learn how to distinguish between cats and dogs. Think how hard it is for you to tell the computers to learn the difference between cats and dogs. However, you can do that easily. Even inside of the cats, you can understand that there are many different types of the cats. How do you really distinguish those? You learn those things by experiences, and you basically try to group them into cats and dogs, and then in each groups you can go further and then make even subclasses of those. You can obviously tell the difference between a tiger and a pet cat, right? So those are the things that simulating the human minds, and we trying to do that is what we call the clustering. Based on the attributes that provided, you try to group things similar things into a group, and you try to separate things from other groups when they are different. So this is the major thing about the clustering. So for, again, unsupervised learning, there is no predefined classes. Come back to this example again. You are basically given a bunch of animals, small animals, and you simply, based on your observation, saying that you separate them into two groups. And then you realize one group is called cats. When you really try to learn among that clusters, and the other cluster is the dogs. So you need additional information when you look into your clusters and then try to understand what is the meaning of each cluster. However, while you are doing the clustering analysis, group them into two groups, you don't really have that cat or dog's label being provided. You simply using their features to separate those. So Typical application for clustering can be a standalone tool to get insights of the data distribution. So that's like one way of doing so. The other one is that we can even use this one as a pre-processing step. Instead of a data mining main body itself, you try to pre-process the data, probably finding the interesting target group so that you can divide the whole major data set into, say, 5 smaller data sets, and you only study one of the interesting group. And this is what clustering can provide. So clustering is a rich it has many different applications. It can be used into pattern recognition, as we mentioned, cats and dogs. We can even use that into like medical analysis, saying that this is cancer images or non-cancer patients images. It can be used into spatial data analysis. So one of the most popular things that recently combined with computer is the GIS, Geographical Informatic System. So based on like Google Map, look into the aerial picture or satellite pictures, you can easily group those things into mountains, rivers, cities, etc. And that is actually a very good application into clustering. We can detect spatial clusters for other spatial mining tasks. Image processing, like we mentioned, most of the images can be easily dissected into, say, RGB for each pixel. And by looking into the pixel as well as their connectivities, you can cluster those things by color, by shape, by many different things. It is useful in economic science, especially in the market research, predicting the market, looking into the patterns of the market. Those things are very useful. Not to mention, World Wide Web is going to be one of the most popular things, like Amazon. They have used this kind of properties a lot so that they can understand customers. They can do the document classification. They can do cluster web log data to discover groups of similar access patterns, which one of the important topic is that how do you convert the hit ratio. So when customers are looking at the website, or touching or doing the cart, making the shopping carts, adding items into the shopping carts, how can you increase what they call the conversion rate? It's going to be important things that we want to discuss in this topic. So, what is a good cluster? Since we already know that we want to put similar things together, obviously, that is one important criteria. So a good clustering method will produce high-quality clusters with the following 2 important things. First of all, high intra-cluster similarity. So if you put things into one cluster, they all need to be similar to one another. Though interclass similarity, which means that between clusters you generated, say you generate 2 clusters, the 2 clusters are supposed to be as far away as possible, so that you want to make them have low intercluster similarity. So you want to make sure they are dissimilar to the objects in other clusters. So those are the 2 major criteria that we will be able to use to evaluate the cluster in computer science point of view. The quality of the cluster method is also measured by its ability to discover some or all of the hidden patterns. So you can see that the first part, this is computer science perspective evaluation of the cluster. So those are numbers basically, because we can really numericalize all of these values, high intra-cluster similarity and low interclass similarity. However, remember that based on the topics that you try to do, you need to find out what can hidden information or what can knowledge really brings to you, and that is a second layers of the quality analysis. So there are many different ways of doing the clustering. First one is the most popular one, partition approach. So what it's trying to do is it construct various partitions and then evaluate them by some criteria. For example, intra-cluster distance or inter-cluster distance, or minimizing the sum of square errors. This category of algorithm has many different things. One of the most famous one is called the K-means clustering. The K-means clustering is something very similar to K-means clustering. Once you understand about the K-means clustering, you basically know the other one. And there are many different type of things. In fact, in this class, we want to talk about K-means clustering itself directly. The next category of the clustering is what we call hierarchical approach. So what this approach is try to create a hierarchical decomposition of all the data, forming the hierarchies, and then use that structure to generate the clusters. And one of the most famous one is what we call a hierarchical clustering, which will be discussed in our next class. Density-based approach. So basically, if you try to picture clustering and saying that you can map all the things onto a two-dimensional space, and by looking into the density of an area, you will be able to form clusters in your mind. Computers can do similar things, and when we try to let computers to learn this type of things, this is what we call a density-based approach. On top of these three major categories of the approaches, there are many other different types of approaches. On top of that, each approach has many different types of algorithms to learn. For example, grid-based approach, model-based approach, frequent pattern-based approach, user-guided or constraint-based approach. All of these are pretty famous, important data mining algorithms or data mining categories using clustering concepts. So all of these are important, and it shows you how important it is for clustering, even though it does not have the predefined label. It is actually super useful for computers to learn the patterns by itself. So let us directly dive into one of the most famous clustering algorithm, which is the K-means cluster algorithm, and that belongs to our very first categories of the clustering approach, partitioning methods. So for partitioning methods, the basic concept is that it constructs a partition of the database D of several objects into K cluster, into several clusters. In the famous K-means clustering, that K has to be predefined by user. So user need to have some knowledge, saying that based on this data set, I think 2 clusters is going to be good enough. Or you say, oh, this is a large amount of the data, so I may want to partition this into 8 clusters. So that K is a very important thing in the K-means clustering. Once we have defined that K number, we want to minimize the sum of squared error distance between all of the clusters, and that is the basic idea of the partition method. So for K-means clustering, let's look into K-means clustering directly. Given K, find a partition of K clusters that optimize the chosen partition criteria. Saying that we want to find a global optimum is basically exhaustive search all of the partitions. Without doing K-means clustering, say before K-means clustering was given, you probably want to try all kinds of different partitions. Computers can do that. However, think about this. When the number of the data set goes to millions, can you really try all kinds of combinations by a given number of K? Say 3 clusters and I have 1 million points. Of course, I can use the computer to globally search for the optimal solution by try all kinds of combinations. However, it will take forever to do so. That's why in a heuristic approach, we have k-means clustering, luckily, been proposed in 1967. This is probably one of the oldest data mining algorithms that's been proposed. However, this is still one of the most popular clustering algorithms used in these research days. So this is something super smart, super simple, and very, very useful. K-Meidai's algorithm is a modification of the k-means clustering. After 20 years, it has been proposed, and we will also address this one in the end of the k-means clustering topic. So what exactly is the k-means clustering? Well, k-means clustering can be divided into 4 steps. Now try to think about how would you want to program this. The first one is that partition objects into k non-empty subsets. Once that is done, we want to compute seed points as the centroid of the clusters, so that in the original k-means clustering, say I want k equals to 2, then what you will do is that you randomly select 2 points among all of your data set. And then you try to look into all the data set inside of your data. One by one, you try to assign that point to the closer cluster. Say again, k equals to 2, so you have 2 points. Now, for your first point, you calculate your distance between the 2 clusters, and you are assigned to the closer one. And you will do that for all of the points. So once you finish that, you have 2 groups. Now use those 2 groups to calculate the new center. That's what the 4th step do, is that go back to step number 2, recalculate the center, and then repeat the step number 3, forming 2 clusters again, and then keep repeating step 2 and 3 until no points has changed. The centroid, the center of the clusters, has no movements or move slower than a certain threshold. And that is the idea of the k-means clustering. It may sound a little bit complicated in terms of the pseudocode perspective, but when we go into the example, everything becomes super easy. So saying that, now this is the data set that we have, and we have only 7 data in this example. I usually like to give some meanings about this 2-dimensional space. So saying that we are a Toyota dealer, and I have a data set of customers' age versus customers' income. And therefore, you can look in here, point number 2 is someone that has low income and a young kids over here. On the contrary, point 6 indicating someone is older with higher income. So take a look at this. Saying that I want to do clustering on these 7 points. So what I would do is that for the very first step, I decide my k equals to 2. And then I will randomly pick up 2 points. Just use the random function of the program, pick up 2 points, assuming I pick up the point 2 and point 7 as my random selected points. Next, what I would need to do is that write a for loop, go through every single items, including the node 2 and node 7. So what you will do, starting with node number 1, what you will do is you calculate the distance between 1 and 2 and between 1 and 7. Then you assign yourself to the closer one. Repeat that process for node 2. Calculate the distance between yourself and the distance to the other centroids. Obviously, 2 has no distance between the 2, so it will assign to itself. Node 3 will do the same thing, assign to the closer one. 4, 5, 6 will assign to the node of 7. In this case, we're forming 2 clusters, but that's not the end of it. We are at step number 3 now. Now, step number 4 will ask us go back to step number 2. We need to regenerate the center based on the clusters that we have. At this time, we can take the average of all the points and we will be able to find the new centers. Obviously, the center location they moved. It moved from node 2 to this location. It moved from node 7 to this location. So obviously, it's not something stable. So we need to repeat the process. Now, what we need to do is that we need to repeat the same process, calculating the distance 1 to this point, distance 1 to this center. And when we repeat the whole process, you will realize node 1, 2, and 3 still assigning to this center, 4, 5, 6, 7 still assigned to this center, so that when we repeat the process, we will understand the new centers has not changing its location. That's when we know these two clusters are stable now, and therefore we're forming two clusters successfully. Referring back to the Toyota dealer concept, now I have two clusters. So I have successfully grouping my customers into two clusters now. Today, I have some new Scion TC cheaper car designed for younger generations. I would know this is actually the group of customers that I want to promote on. On the other side, saying I have some Lexus new cars comes out, I would probably want to introduce to this group of people. Saying that I have another group in here, if that is the case, that's indicating that some younger generations with higher incomes. In that case, if I have some very sporty car, Supra, comes out to the market, I would probably want to target that customers over here. So you can see that this is something that you can use and to promote things, to use as business strategies for you to generate better revenues. So this is another visualization to show you what is going on, saying that we have this kind of data randomly. We select 2 points and we will be able to generate two clusters looks like this, and then finding the centers of that, of course, is not converged yet. So we need to reassign, regenerate the center, and then we need to repeat the process until the new centers are not changing anymore. So this gives you another visualization of how k-means clustering has been implemented. Before I sums up this k-means clustering, I want to make sure you guys really understand what is going on. So I'm creating additional example to show you how exactly it is going on in a one-dimensional, very simple data set. So in this case, you can see that we have several points over here, and with the dots indicating there is a data over there. So we currently have so many different data. At this time, saying that instead of k equal to 2, I want to k equal to 3 this time. So again, what's happening here is that the program will randomly select 3 points, saying that we have randomly select node of 3, 16, and 25 as the initial centroids. So what is going on next is that each point of the data set, 2 will calculate the distance between 2 and 3, 2 and 16, 2 and 25, and then assign to the closer one. So when we do that operation, goes through all the data sets, you will see the node 3 as the centroid will cover these nodes. Node 16 will cover these nodes. Node 25 will cover these nodes. And based on that, we would be able to recalculate their centroid, and then we will repeat the process. So and the next step is that we do the same thing. We try to group them based on the new centers. And we will find out that they are actually go into the same clusters. And that's why we will be able to know the new centers and the centers that we try to do are exactly the same. And we will understand we can keep doing this. However, when we keep doing this, the centers will always stay at the same location. That means there's no changes anymore, and that's why we don't need to continue. And that's why we can stop over there reporting that we can form 3 clusters with these 3 new locations. To make sure you really understand this, now I want you guys to use the same data set, same number of the clusters. The only difference is that I want you guys to have different initial locations, because obviously when we use random locations to select initial centroids, they would do different locations. And let's see what is going on when we try to form the 3 clusters over here. So that is what I want you guys to do for the class assignments. In this video, we have introduced the basic idea of the k-means clustering. In our next video, we want to look a little bit deeper into the k-means cluster.